Okay. All right, let's get started. So this is class 5. Overview of today's class. We're gonna just go over it, see if anyone has any questions about last class's homework. Then we're gonna move on and talk about some rational expressions and equations, extraneous solutions, radical functions, rational exponents, rationalizing denominators, analyzing rational functions, and then just wrap up and questions. So a lot of fraction stuff today and functions. Okay. Right. So first off, does anyone have any questions about last week's homework or just about any homework in general? Of course, if you haven't already submitted it, you still have time. Even if you submit it late, that's fine. I'd be happy to look over it and just give you some feedback. Okay. Right. I do not see any questions, so I'll keep going. So first off, we're going to talk about rational expressions and equations. Today is probably going to be a lot of like rules, formulas, and kind of not necessarily memorization, but just a lot of things to know. And we're going to, of course, go through a lot of examples. So rational expressions and equations. So I think this should be mostly review. So for any rational expression, PQ, and the polynomial R, where of course R does not equal 0, P times R, PR divided by QR is equal to PQ times R over R. Of course, any number over itself will always equal 1, so it will just equal PQ. And then adding and subtracting, of course, when you're adding and subtracting two fractions, you will need, or just two expressions in general, you will need to have a common denominator. That's the most important part. And then just for dividing rational expressions, when you're dividing, you have to take the reciprocal of the second fraction or the second expression. In other words, just flip it around. Make the denominator the numerator and the numerator the denominator. And then you just multiply and you get your answer. So pretty much review. And then let's see, next slide. So this is a meme I found on the internet. Brace yourself, fractions are coming. All right, so here are a few examples. Let's just take like 5 minutes to work through these. Once you've finished them, and just put your answers in the chat box, and then I'll go over them as a class. So just keep in mind when you're doing all of these, to make sure that you put them into the simplest form. All right, we'll go until 3:42. Just take a few minutes to work on them, and once you finish, just type your answers in the chat box. Of course, if you don't get to all of them, that's also completely fine. You can just put in whatever you have so far. And then while you guys are working, I'll just slowly start working on the first problem, so you can kind of see how I do it. And if you're stuck, you can also reference it. All right, if you haven't already, just put your answers into the chat box. And then afterwards, after you put your answers into the chat box, I'll take a look at them, and then I'll go over these questions. All right, I'll go over the answers now. So for the first one, I already showed it, but so when you are solving these, when you're simplifying, I should say, these type of problems, you just want to see how much you can break each part down. So for example, in this first problem, the x cubed plus 27, you can break that down using the using cubes. So x, that simplifies or goes into x plus 3 times x squared minus 3x plus 9. And then you just and then you have the 4x to the third. And then down below, you can take out the -2, and then you get x plus 3, and then you just have this number, this very nice number, x squared minus 3x plus 9. So then afterwards, you can very easily just cancel them out, cancel out the top and bottom. 4x cubed divided by -2x is -2x to the third. So this is just you can very easily simplify these by finding, what similarities do the top and bottom have. Okay. So next, for this one, of course, you want to first flip the second fraction around, so you have the reciprocal, and then of course you would want to factor all of this. So on the top, you would get the 8z squared plus 14z plus 3 simplifies to 4z plus 1 times 2z plus 3. The top, which would now be 35z squared plus 3z minus 2, you can simplify that to 3. You can factor that, into 7z plus 2 times 5z minus 1. Right here. And then for the bottom, you get 4z plus 1 times 5z minus 1. And then for the bottom, right, you have 2z plus 3 times z plus 2. And now we have a lot of numbers that we can cancel out right here. So 4z plus 1 and 4z plus 1, you can just cancel that out very easily. And then the 5z minus 1 and the 5z minus 1, that cancels out. And then the 2z plus 3 and the 2z plus 3. And then all you have left is colors. All you have left is 7z plus 2 divided by z plus 2. So it's very in order to simplify these kind of fractions or expressions, just keep in mind the first step that you always want to do is factor every single one of these individual expressions as much as you can, and then of course look at what can be canceled out. Finally, for this one is a bit more complicated. So we have x minus 5 and then x squared minus 5x. So right here, right away, you can see that the only difference between these two is an x. And this one right here, the only difference is x minus 5. So you want to, of course, have it so that they all have a common denominator. So the first one would be 6x. The top, let me put that up, 6x. This one would just stay x minus 35. And then lastly, this one, you would get 2x minus 10 when you multiply. So afterwards, you combine all of these top numbers, you add them together. And afterwards, you would get you would get 6x plus x minus 35. Make sure to, very important, make sure to keep the symbols in mind, because you have the negative here. It would be negative 2x plus 10. All right, and then at the bottom, we have x squared minus 5x. And then from here, the top turns into 5x minus 25. Bottom still stays the same. And then from here, you can see that we can factor even more. We can take out an x minus 5 from both the top and the bottom. Those two cancel out. So all we are left with is 5 divided by x. Does anyone have any questions about the process, or how I got these answers, or just anything in general? All right. I do not see any questions, so I will keep on moving along. All right. So these are some more complex fraction examples. Let's take about 5 minutes to work on these. We'll reconvene at 3:53. Once you solve the problem, just put the answer in the chat box. Again, if I will do the first one, so for the first one, sorry, you would want to set it up like 3a divided by 25b squared. And then, of course, and then that would be, the whole thing is divided by 9a squared over 5b. So in order to change the division symbol into a multiplication symbol, you just flip it around. So you get 5b divided by 9a squared. And with that, you would want to multiply these two numbers. After you multiply, you would get, so first, you would, it didn't represent it super well, but you can cancel out numbers from here. From 25b, you can just get 5b. And then from 9a squared and 3a, you just get 1 and you get 3a. So then in the end, you're just left with 1 over 15 b a, or ab, and that would be your final answer. So let's just take we'll take 5 minutes, work on these 3 problems, and then once you solve the problem, just put your answer into the chat box. Okay, we'll take about 2 more minutes. Just finish what you can do. And then afterwards, just put your answers into the chat box. It's fine if you don't get to all of them. All right, just put your answers into the chat box. It's fine if you didn't get to all of them, but once you put your answers in the chat box, I'll take a look at them, and then we'll go over the answers. All right. Okay. So for number 1, you would get, after simplifying, you would get, let me type it down. X times x plus 5 divided by 2 times x minus 5. You would get this by first, you would get the opposite reciprocals. You would get 6x. And then, sorry, x minus 5, x plus 5. And then you would get 12 on the bottom. Right? These cancel out. You get 2 on the bottom. You are left with x up here. X times x plus 5. And then x 2 times x minus 5. For the sake of time, I'm not going to go over and explain the other answers super in depth. But if you want me to, just put it, message me in the chat box, and I'll be happy to go over any specific question. For the third one, you would get negative x squared divided by y squared. And then for the last one, you would get 2y plus 3x divided by y minus 2x. Okay. Does anyone have a specific problem that they would like me to go over, or any questions that they have about any of these answers? Okay, I do not see any questions, so I will keep on moving along. All right, now we're going to be talking about extraneous solutions. So what are extraneous solutions? Extraneous solutions are just a solution to the equation, which makes the denominator of that equation 0. Because as you know, a fraction can have a numerator of 0, but a fraction cannot have a denominator of 0. That does not work. Okay, so I will do the first one. For the sake of time, I'll skip most of the steps. But afterwards, after some intensive solving, you would get 0 equals 3x minus 1 times x plus 1. Firstly, of course, you would move. You can move this to this side of the equation, and it becomes negative. And then you would have to multiply it by 3x minus 1 and this side by x, so they have the common denominator. But anyways, from this, you can see that we have two solutions. We have x equals 1 over 3, or x equals -1, right? And typically, you would use the fancy curly brackets and just say, oh, -1 comma 1/3. But this is where you have to be careful. You have to double check if the solutions are extraneous. So how do you check if a solution is extraneous or not? You would, very simple, you can just plug the answer back into the equation to double check. So for example, if we plug 1 over 3 back into the equation, right, what do we get? So here, this just cancels out to 1. This bottom cancels out to 0. This becomes 3. Let me redo that. 3 is not good. So this whole, the middle would be 3. And then this side would also become, the bottom would be 0. And as we know, 1 over 0 is not, you can't do that. A fraction cannot be divided by 0. So therefore it is an extraneous solution, because you have this you get this wonky answer of 1 over 0 plus 3 equals 1 over 0. So this answer would not work. And of course, if you cancel out the 1 over 0 on both sides, you would get 3 equals 0, which is obviously not true. So that equation just does not work as a whole. But then, of course, if we plug in -1 into the answer, you would get, for this side, you would get positive 3 over 4 minus 1 equals 1 over -4. So what you would get is you would get 3 over 4 minus 1 equals -1 over 4. And if you solve that, it is true. So in this case, the -1 would not be an extraneous solution. It perfectly fits. When you plug it back in, the equation works out. Both sides of the equation are equal. So therefore, -1 is a solution. Of course, after you find out if there is an extraneous solution or not, you would have to take it out of the solution set. So therefore, 1 over 3 is not a solution. But of course, if you ever run into a problem on a test or a quiz that says, list the extraneous solutions, you would, of course, just list 1 over 3 for this problem. You would not list -1 because it is not an extraneous solution. Okay, let's take 2 minutes and just work on the second problem, and then find the extraneous solution, find the real solution and the extraneous solution of the problem. After you're done, just type the extraneous solution and the real solution into the chat box, and I'll take a look at it. Okay, if you haven't already, just put your answer into the chat box. I'll take a look at it, and then we'll go over question number 2. All right, now I will go over question number 2. So for question number 2, we can just simply take out the x minus 3 on both sides. Because the denominator is the same for both fractions, we can just cancel that out very easily. And then in the equation, we are just left with x plus 5 minus 2x minus 2 equals 0, of course. And then after, we can simplify that. So we would get negative x equals negative 3, which equals x equals 3. So now you might be thinking that since there is only one answer, that x must equal 3, right? But that is not always necessarily the case. And when we plug it in, we see that the denominator of both sides of the equation are equal to 0. The top becomes 8, and this top also becomes 8. But the thing is, we cannot have, although it is equal that on both sides of the fraction, it is 8 over 0 is equal to 8 over 0. But as I've said before, you cannot have a fraction that has a denominator of 0. So in this case, the answer would be no solution. And you can write no solution as a 0 with a line through it. Also, for a no solution, you can draw a set of empty curly brackets. Those two both denote no solution. So either of those usually work. I prefer the curly brackets, but I would say both of these are viable answers to the problem. Okay, now we're going to be talking about some radical functions. This is just some quick vocabulary about radical functions. So this part, the n is called the index. The radical is the square root, the entire square root. And then the radicand is what is in the square root itself. It is the x plus y in this case. And then here are just some basic radical function rules to be aware of. So finding the nth root of a to the nth power. So if n is an even positive integer, then the nth root of a to the n is equal to the absolute value of a. And then if n is an odd positive integer, then the nth root of a to the n is equal to a. This is because of when we've dealt with powers, when you have any number that is in even power, the number always comes out to positive, right? If it's like -3 squared, it comes out to 9. But whereas if it is an odd power, like for example, -3 to the third, that's -27. So that's just why for an odd positive integer, it is just the number itself, whereas for an even integer, it is the absolute value of a. The product rule of radicals. So if the nth root of a and the nth root of b are real numbers, then the nth root of a times b is equal to the nth root of a times the nth root of b. The quotient rule, very similar as well. So the nth root of a divided by b is equal to the nth root of a divided by the nth root of b. And also very important, b cannot equal 0 because then it wouldn't be a real fraction. And then the cube root of a is written as 3 root a. And the cube root of a is only equal to b if b cubed is equal to a. So these are just some important rules to keep in mind when you're solving radicals. These will help you. These will greatly help you in saving time and just solving equations, simplifying equations in general when you're dealing with radical functions. So here we just have some pretty quick examples. We have your goal for these examples are just to simplify. I'll do the first the first few. So if you've seen this, you should, if you've been to the past classes, you should know that this will involve I, the first one, because I is equal to the square root of -1. So you would take out I, and then afterwards you are left with I. The color isn't right. You are left with I root 25, which equals plus or minus 5I. Okay, and then for the next one, you just you take the square root of it, and the square root of x to the 10th is just x to the 5th. And then lastly, for this one, the cube root of 1/64. You can simplify that. I don't know how to express it, but I'll just say, excuse me, 3 root, just pretend that means the cube root of the cube root of 1 divided by the cube root of 64. And then the cube root of 64 is 4. So for this answer, we would just get 1/4. Let's take 5 minutes and just work on these 3 problems. Let me mark them. So let's just work on 1, 2, and 3. Let's take 3 minutes. Let's say the last number 2 and number 3 are pretty easy. If you reference back to, I'll just go back to it really quick. If you use this property, if n is an even positive integer, then the nth root of a to the nth is just the absolute value of a. And then if n is an odd positive integer, then the nth root of a to the nth is just a. So that should help you guys get through number 2 and 3 pretty quickly. So we'll just take 2 to 3 minutes and work through problems 1, 2, and 3. All right, we'll take about another minute, and then afterwards, just put whatever answers you have into the chat box. Alrighty. Okay, if you haven't already, just put your answers into the chat boxes. Okay. So for number one right here, what we have is if you look at this, you can see that it is a perfect square function. So you have x to the x plus 3 squared. It's inside. And of course, if we reference the rule that we talked about in the previous slide, if n is an even positive integer, then n to the root a to the nth is equal to the absolute value of a. Right here, we can see that even though it isn't shown, the number right here is 2. So what can we do? We can just cancel these out, and then we are left with the absolute value of x plus 3 as our answer. The same goes for these two answers as well. Since these are the same, you can cancel it out, and you just get the absolute value of x plus 6. For this one, though, you have to be careful. Since it is an odd power, you just have 7x minus 1. No absolute value needed for this one. Does anyone have any questions as to how I got these answers? Okay, I do not see any questions, so I will keep on going. Okay, so more definitions. A lot of definitions. It's fine if you don't remember all of them. I'll be posting the slideshow on Google Classroom right after the class. So if you're confused about any of these, or if you forget them, you can always refer back to the slideshow to review. So these are some definitions. So the definition of 1 divided by 1 to the a to the power of 1 over n. So that would equal the nth root of a, which makes sense if you think about it. If you think about 1 as kind of the power that a is being applied to, and then n is the number that the whole thing is getting divided by. And then a to the m divided by nth power is equal to the nth root of a to the m, or you can rewrite it as the nth root of a to the mth power, whichever one you prefer. Both versions, remember, keep these in mind as when you are in Algebra 2, when you are dealing with these radical exponents, when you're working through them, these will come in handy in helping you simplify. And then the definition of a, the negative n over m divided by n. So just like any other negative exponent, you would first take the reciprocal. So 1 divided by a to the m divided by n. And of course, you can just take what you have from the second rule. You can take what you have from the second rule here and just make this into 1 divided by the nth root of a to the m if you want. Okay. So here are some examples that we'll quickly work through. So I'll do a few of them first. So for the first question, what we have here would be root the 5th root of x, because as we talked about in the previous slide, the 1, this number, the denominator of the exponent is what goes outside the square root, and the 1, what is this number? It is the power inside the square root that is being applied to x. And then I'll do the second one as well. This one would be through the cube root of negative 27y to the 6. And then, of course, from here, you can simplify it. You can simplify it even further. From here, y to the 6, the cube root of y to the 6 is just y squared. And then the cube root of negative 27 is just negative 3. So for the answer to the second one, you would get negative 3y squared as the answer. Very nice looking number. Let's take about 5 minutes to work through these problems. They should be relatively straightforward. If you have any questions, just let me know. Okay, because we're running a bit low on time, just put whatever you have into whatever answers you've gotten so far into the chat box, and I'll take a look at them. It's completely fine if you didn't get to all of them. Okay. So for the first one, it's a tricky problem. Make sure that you look closely, that the exponent is only being applied to x. It isn't being applied to 7. 7 just stays as is. So it would be 7 times the 5th root of x, right? Next one, you would get negative 64. For the next one, you get 1 over 8. The next one, you would just get the seventh root of 2x plus 1 squared. And then for the last one, you would get negative 1 divided by 64. Does anyone have any questions as to how I got these answers or how I solve them. Okay, I do not see any questions, so I will keep on going. These are some more examples. We can just skip them for now. All right, adding, subtracting, and multiplying radicals. So radicals with the same radical index and same radicand are like radicals. Remember, the index is just the number outside the square root, and the radical is the whatever expression is inside of the square root. So those two have to be the same. If both sides of the equation are raised to the same power, all solutions of the original equation are among the solutions of the new equation. This is pretty much just a fancy way of saying if you raise both sides to the same power, the equation, your answers will stay the same. It won't change anything. Much like if you multiply each side of both sides of the equation by the same number. All right, here are some examples. I'm just gonna skip the examples since we are a bit short on time, but I'll just quickly talk about it just to show you. So for example, here you can see that the index, which is the 3, they're the same. And then the number, the radicand, the number inside the fraction, not the fraction, the square root is the same. So in this case, you can totally simplify it. And then for this one, at first, it may look like you can't simplify it, but keep in mind, you can turn this into root 2 times root 9. Root 9 becomes 3. And this one, you can simplify it to 2 root 2 times root 25. And then root 25 just turns into 5. So all of a sudden, you have these two, you have two numbers that can be combined. You have 5 root 2 plus 15 root 2. 5 root 2 plus 15 root 2. And all of a sudden you can combine them and you would just get 20 root 2. So make sure that when you're looking at these problems, don't just look at it and say, oh, the radicand, the number inside is different. I can't simplify it. Make sure that you look closely, see if there's any square roots that you can, numbers that can be square rooted very nicely can be taken out. All right, next up, rationalizing denominators. This is just, you can quickly read through it, but the main point is that the denominator of a fraction cannot have a square root in it, because when you have a square root in the denominator, mathematicians just don't like that. I myself, I'm not particularly sure of why they don't like it, but it's just something that we have to do. So first, if the fraction is in the form of x divided by the root y, then it's pretty simple. You just multiply it by the fraction by root y over root y, which is also equal to 1. Then you get x times root y divided by y. And then tying in what we learned last class, I believe, talking about conjugates. So if the fraction is in the form of x divided by a plus root b, then you would take the conjugate of it, which the conjugate of a plus root b is a minus root b. You flip the symbol, and then you would get, so you have a minus root b divided by a minus root b, which is just equal to 1. Multiply, you get ax minus x root b divided by a squared minus b. So then voila, the denominators do not have any square roots in it. And then here are these are just some examples. And okay, so does anyone have any other questions?